Climate change is an inherently multidisciplinary problem. It's going to impact upon all areas of the economy and society. We have members of the Walker Institute from a range of departments, including meteorology, agriculture, geography, soil science, economics, construction management and so on, bringing together the range of skills that we need to address the serious challenges posed by climate change.
So I think over the last couple of years there's been a major shift in public perception on climate change, to going away from the question, is it really real, is it actually happening? And I think now with the Stern Review and the Intergovernmental Panel of Climate Change Fourth Assessment Report, both of which we contributed to, I think the answer is now yes, it is happening, it is real. And I think the questions are now moving to, well, what are we going to do about it? How are we going to adapt to the changes that are coming? How bad is it going to be? So it's becoming really a very important area of research generally, and particularly in this university, because we have such really deep strengths in the important maths and physics that underpin the way in which we predict what will happen to the climate.
When we think of climate change, we tend to think of the middle or the end of the 21st century. But when we're trying to adapt to climate change, we often need information on the next 10, 20 or 30 years. And that's quite a challenging timescale, because not only have we got the effects of climate change to worry about, we've also got natural variability in the weather and climate system. So what we're doing here at the university, together with partners such as the Met Office Hadley Centre, are developing ways to see how we can forecast over the next 10, 20 years how the combination of natural variability and climate change will impact upon weather and climate.
Climate research, it is a science, but it's not really quite like a traditional science where you have a laboratory and you can do experiments. The climate is out there, it's all around us, and it involves very complex interactions between the atmosphere, the ocean, the land surface, ice sheets, vegetation, everything. And obviously to unravel how it all works and how it's going to respond to, say, increases in carbon dioxide in the atmosphere is very complicated, and the only way we can actually do that is by using numerical models that try and represent or simulate the system in all its complexity. One of the key areas we work in is on tropical climate and how that will be affected by global warming. And this is a really important area because, as Nick Stern noted in his review in 2006, it is the poor in the developing world that will be most affected by climate change.
One of the key challenges in estimating the consequences of climate change is to go from the large scale that climate models operate at, that's the global scale, down to the local scale, the scale of the catchment or the urban area, for example. And in order to do that, we need to be able to link mathematical models of the systems that we're interested in, maybe a catchment, maybe a building, maybe a field of wheat, link those with the information we can get from climate models in order to make credible estimates of what might happen to these systems in the future. So, for example, we have procedures and developed methods to try and use the very high resolution climate model output to estimate changes in stream flows or crop growth in particular areas. We can use this information in two ways. The first is just to get some idea of what the extent of the issue and the nature of the problem is, a sort of scientific investigation really to scope what the challenges are. The second way we can use this information is to help inform decisions by government or business or industry in order to adapt to the changing climate. Because we know climate will be changing, it will be impacting upon crop growth or water resources, and organisations need to be able to use this information to make sensible and sound adaptation decisions.
There's of course an increasing call on us to provide our expertise, and they're challenging us as scientists to take perhaps a different look at the way in which we interpret the work that we do. So I think this is a really exciting opportunity for the university to extend the research and to make it highly relevant to everybody, to industry, to government, to the person in the street. So it's a very exciting period to be working in this area.